Hello, this is a video that shows the functionality of the Dynamic Design Pharma's GIT XA1 glove integrity tester. What you see in front of you right now is two key components of the system. The one to the right is the electronic controller, and the one to the left is glove port interface. Typically, we develop a glove port interface to the isolator glove port of your system. Our standard design is what you see in front of you, and basically what you're seeing here is machine components which match the geometry of the glove port, and then a molded seal that we mold here at DDP that compresses when you turn the knobs of the interface. So I'm going to install that, and I'll show how easy it is to do that. So I just hold that in place, and I turn the knobs, alternating them, nice and tight. And that's all it takes to install the interface. Okay. So, as I said, on the right side is the controller. And that's already all set up to run the leak test cycle. So I'm going to go ahead and start the cycle so that while that's going on, I can describe what's happening. What you're hearing right now is a little compressor that is inside of the unit, and that compressor is pressurizing the glove that, of course, is attached to the glove port. The glove is not quite visible right here, but basically, during the inflate cycle, we pressurize the glove until it reaches a programmed pressure level. Once that's reached, the machine goes into a no overpressure condition where it stabilizes the glove at the programmed pressure level. The idea here is to create as much as possible, stretch the glove to a level where it's somewhat resembling of a solid container. Of course, being that it's rubber, that's almost impossible, but we have found that by pulsing it, and you can hear the pulsing going on, by pulsing it at some pressure, we pre-stretch the rubber to some level, and once that the stretching is completed, we deflate to the leak test process. As clearly the leak test, the methodology of the leak test process is based on pressure decay. The concept is to inflate the volume of the glove to an X value, X pressure, and then seal up the system using obviously internal valves, and then just wait. Need to wait for a programmed period of time, and at the end of the wait, of course, we look at the pressure, internal pressure, and if it is above a certain point, clearly the glove is passing, it's good, and if it's below that certain point, the glove has failed. Right now the machine is going through what's called the deflate portion of the cycle. We went to an overpressure where we stabilized the rubber at some pressure level that is programmed, and now it's deflating to the pressure that is the starting pressure of the leak test cycle. It just switched over to leak test, so now we start the leak test cycle. What I have programmed in here, just for the purpose of this video, is a short cycle that is about 4 minutes long total. Typically, to find a reasonably small orifice size in this type of gauntlet or a full-size sleeve, the leak test cycle is around 10 minutes, between 6 and 10 minutes. But I programmed a short cycle just for the purpose of the video. So we have 142 seconds counting down until the end of the test. So at the end of the test, we have four options for outputting the data, and those are all programmable settings in the machine that only a supervisor or administrator level can actually change. One method is, of course, to print the results on the local thermal printer, and then another possible way is to print on a remote printer via an Ethernet connection. The third one is to store the data internally to the machine and then download the data directly to a computer via a USB port located in the back. And then a fourth way is to take the same electronic data and download it onto a flash drive, so that then it can be transferred onto a computer. So the leak test cycle is progressing. We have about 60 seconds left, and at that time we'll be able to output the data. Now, there's a functionality in here that can be turned on and off that allows to shorten the leak test cycle if it is programmed to do so. Basically, if the glove is determined by a machine that it is leaking, in other words, if the pressure drops below the pass-fail pressure level for a duration of 10 seconds, then it really doesn't make sense to continue the full duration of the cycle. So the machine can be programmed to say, well, if the shortened cycle, we call a shortened cycle, function is active, then the machine will automatically say, hey, this glove is no good, I need to take some action. A couple words about the access for security purposes. There are 3 levels. One level is the administrator that has access to all functions. The second level is supervisor, which has access to all functions except for password type functionalities. And then, of course, the operator. All the operator can do is run the leak test cycle. What you just heard is the beeper that indicates that the leak test cycle has concluded. And the display on the screen actually shows that it is a passing cycle. I'm going to hit the button to output the results. And I have it programmed where it's going to output to a local printer located 5 feet away from the machine here. And I will show the printout, basically what the data packet of each leak test cycle contains. Now, when you output the data in electronic form, that's being outputted as a CSV file, so it's comma separated values, and that CSV file clearly drops right into Excel very nicely, and therefore it can be obviously looked at, and each cycle is individually identified by a number of things. So I'm going to show the printout here, and so the title up here as a date stamp and a time stamp, also serial number of the machine that is being used. Below that is login data. It shows that the person I logged in as a supervisor 1, and my name is Don, which it isn't, but that's okay. Parameters, these are for each data packet. We have decided to print out the parameter set, and the reason for that is so that there's no question what parameters were used to run the leak test cycle. And then, of course, this is the cycle test results. Notice that each cycle has a cycle number assigned. That's a unique cycle number that is stored within the machine. It cannot be changed, so that for traceability of data, it is important that each cycle number is tracked. Of course, the test result is pass. I entered that the glove that was being tested was 1. So if you have multiple gloves on your machine, naturally you can identify them with 1, 2, 3 through N. And then also the end pressure is being printed here. And the total cycle time was 317 seconds. So that's the machine, and thank you for listening, and have a great day.